And we start with a to-do list. So I have created a quiz number 2. I'm going to post it after class on Canvas. It's due a week from today, which is Monday the 12th. Okay, and then the day that's due is when we start the second test, exam 2, on WebAssign. And you have a week to finish it, so it's due on the 19th. I also want to remind you that there's some homework due this Saturday, and I want to talk about the sections that will be on the quiz and the exam. So both of these, let's go. We'll have questions from, let's see, 2.7 to 3.5. And then the last thing to talk about is the final exam. So in this class, I would like to get through the first few sections of chapter 5, but I don't think we're going to include chapter 5 on the test. We will do homework, we will practice. And the final exam will probably have a few cumulative questions, but mostly focus on sections 3.6 to 4.9. So it'll kind of be like our third exam. Maybe just a few extra questions from other work we've done. Okay, so that's the plan. Any questions? Okay. Let's use notes. We're going to finish 3.11. The quiz has 8 questions, and it's kind of similar to the last quiz we did. I'm going to start working on exam 2 soon, and before we do that test, I will try to get the grade book with all the grades. Get an idea of where you are in class. So 3.11. Hyperbolic functions. So hyperbolic functions continued. So I'm going to try to say it correctly. This would be sinh of x. And we're going to say that this function is odd. We're not going to do the proof, but we're just going to write down what that means. So if you put in a negative x to that function, sinh of x, we get a negative sinh of x. cosh of x is even. So we put in a negative x, it's that function. Next. So cosh of negative x is equal to cosh of x. And I need to load the videos from last week, but we talked about the derivatives of these hyperbolic functions. So I'm going to start doing examples. We're going to let y equal sinh of 3x squared minus 7. Find the derivative. So take derivative with respect to x, dy, dx. Which we call y prime. Okay. We're going to need to use the chain rule. So the derivative of the outer function, then multiply by the derivative of the inner function, and then simplify your answer. Okay. So the derivative of y is equal to cosh of 3x squared minus 7. Okay, multiply by 6x. That's it. I mean, you could write the 6x in the front, but it's the same thing. Next. New example, we have a new function called f of x. Is equal to 5x times tanh of 2x. 5 power x t a n h 2x. Find the derivative with respect to x. F prime of x. All right, we have a product rule. Call this f. It's going to be g. Do f prime g add g prime f. Start here. F prime will be 5 to the x times ln of 5. Then multiply by g, tanh of 2x. Okay, that's the first term. Add this other term, g prime times f. G prime. So hyperbolic secant squared of 2x. And it's chain rule where we multiply by the derivative of 2x. So secant, hyperbolic secant squared 2x multiplied by 2, and then multiply by the function f. So 5 to the x. Cool. Both of these terms have 5 to the x, so we'll factor that out and we'll kind of simplify what's left over. F prime of x is equal to 5 to the x times ln of 5 times tangent of 2x add hyperbolic secant squared of 2x times 2. Let me make sure I got this right. Squared. I'm missing something. Secant squared, leave the 2x, multiply by 2. No, that's good. Just typo on my part. This would be a 2. Cool. Multiplied by, which, you know what, we would read better to have this 2 in the front. So we'll put this down times 2. Okay, looks okay to me. Next. We're going to talk about inverse hyperbolic functions and the derivatives of those. This will be on your homework, but not on the test, just as a side note. Okay. So these are some of the inverse functions for the inverses of the hyperbolic functions. Okay, we're going to do sinh, cosh, and tanh. Inverse of sinh of x. Sin h inverse of x is equal to 1 over the root of x squared plus 1. Cosh inverse of x. The inverse of the hyperbolic cosine function. Okay. This is equal to, oh, oops, yikes. We need to back up. This is a derivative, so scratch that. This is coming soon. Okay, so we need to go back. The inverse of hyperbolic sine is equal to ln of x and then add the root of x squared plus 1. There we go. And then we'll do the derivative later. Cosh inverse of x is equal to, C, is ln of x plus the root of x squared minus 1. And last one I'll write down is the inverse function of hyperbolic tangent. So tangent inverse of x. Okay, this is equal to 1/2 times ln of 1 plus x over 1 minus x. Okay, now we'll do the derivatives for all of the hyperbolic trig functions and examples, and we're done. So, derivatives. Okay, so I already wrote this one down on accident. The derivative with respect to x of sinh inverse of x. So d dx of sin inverse of x will be 1 over 1 plus 1 over the root of 1 plus x squared. Or x squared plus 1, same thing. Next derivative will be of cosh inverse of x. D dx of cosh inverse of x is equal to 1 over the root of x squared minus 1. Then the derivative of tangent inverse of x. Okay, this is equal to 1 over 1, I'm sorry, let me make sure you get it right. 1 over 1 minus x squared. Three more. So we need to do hyperbolic cosecant inverse of x. And take the derivative. So the derivative with respect to x of CSCH inverse of x would be kind of long. It's going to be -1 over the absolute value of x. And that absolute value of x is multiplied by the root of x squared plus 1. We're going on to the derivative of hyperbolic secant, with the inverse of hyperbolic secant. So spelled ICCH, and then we're doing the inverse of that function. Okay, so that derivative is -1 over x multiplied by the root of 1 minus x squared. And then the last one is actually was the same as the derivative of the inverse of hyperbolic tangent. So the inverse of hyperbolic cotangent is also 1 over 1 minus x squared. So COTH inverse of x is equal to 1 over 1 minus x squared. And that's the end of the list of derivatives. So we're going to do, hopefully, some examples. Yeah, we got time. Okay, first one. We're going to let y be equal to sinh inverse of 5 to the x. And then find y prime, the derivative of that function. Okay, so let's see. We're going to use the chain rule. This is the outer function. Multiply the derivative of that with the derivative of the inside function, 5 to the x. Okay, 1 is over the root of 5 to the x squared. Minus 1, no, plus 1. That's taken care of. Multiply by the derivative of 5 to the x, which is 5 to the x times ln of 5. Cool. This is 5 to the x times ln of 5 over the root of 5 to the power 2x, and then add 1. Next example we're going to do. now we've got y equal to tan inverse, forgot the h, tan inverse of sinh of x. Find y prime. So it's a chain rule again. This is your outer function. So we'll do the derivative of this, multiply by the derivative of the inner function, and I think we'll be good to go after that. So we're going to put 1 over 1 minus sine h squared. Oh, is the derivative of tanh is hyperbolic secant squared. So this is SECH squared of x. Okay, multiply by the derivative of sinh of x, which is cosh of x. And that's it. I put this over on the side though. Okay. Last one. We have a function. This. The function is y equal to x cubed times cosh inverse of 2x. Find the derivative. With respect to x. Okay. So that would be y prime, and y prime will involve a product rule. So we're multiplying x cubed, and I'm going to call that my f function. This is going to be g, and you're doing f prime times g at g prime times f. Start here, f prime, be 3x squared, multiply by that. Add, or we can add down here, g prime times f. So a chain rule right here with c. Derivative of cosh inverse is going to be 1 over the root of 2x squared minus 1. And then multiply by the derivative of the inner function, 2x. So we can multiply by 2. And we still need to multiply by f, which was x cubed. And we're going to simplify this. So this is equal to 3 to the x, cost inverse of 2x. 3 times x squared, cost inverse of 2x. Add 2x cubed over the root of 4x squared minus 1. Okay, I think that's it. So I've got that part, check, that are all checks, and that's the end. All right, that means next time we meet, we'll start chapter 4. I think we're just gonna go ahead and call class now.